In this video, we're going to focus on Dalton's law of partial pressure, which basically states that the total pressure of a gas is equal to the sum of the individual partial pressures. So PA plus PB plus PC. So PA is the partial pressure of gas A or substance A. That is the pressure exerted only by those gas molecules. Now, there's different ways you can calculate the partial pressure of a gas. You can use the ideal gas law equation, PV is equal to nRT. Now, if you're going to use this equation, if N represents the moles of substance A, then P will represent the partial pressure of substance A. Likewise, if N represents the moles of substance B, P represents the partial pressure of substance B. If N represents the total moles of all the gas molecules in a container, then P would represent the total pressure of all the gas molecules in that container. So the subscripts between N and P have to match. Now you can also calculate the partial pressure of a gas if you know the mole fraction. For example, the partial pressure of substance A is equal to the mole fraction of that substance times the total pressure. And you can calculate the mole fraction by taking the moles of substance A divided by the total moles within a container. Another way you could find the mole fraction, it's equal to the partial pressure of that substance divided by the total pressure. And keep in mind, the sum of all mole fractions must add up to 1. The mole fraction is basically the decimal form of the percent. For example, 40% is 0.4. So if 40% of all gas molecules is nitrogen, that means the mole fraction of nitrogen is 0.4, for instance. So now let's work on some problems using these equations. Let's try this problem. A storage tank contains 2 moles of argon, 3 moles of O2, and 5 moles of N2 at a total pressure of 1,000 torr. Calculate the partial pressure of each gas. So first, let's calculate the mole fraction. The mole fraction of argon is equal to the moles of argon divided by the total moles in the container. So we have 2 moles of argon, and the total moles is it's going to be 2 plus 3 plus 5, which is basically 10. So the mole fraction of argon is 2 over 10, which is 1 over 5. Now what about the mole fraction of O2? So there's 3 moles of oxygen out of a total of 10 moles in the container. So that's the mole fraction of O2. The mole fraction of N2 is, let me convert this into a decimal. So for argon, 1 over 5 is 0.2. For O2, 3 over 10 is 0.3. And for N2, it's going to be 5 over 10, which is 1/2, and that's 0.5. So that's the mole fraction of each gas. If you add these 3 numbers, the total mole fraction is equal to 1. 0.2 plus 0.3 plus 0.5 is 1. Now, the fact that we have a mole fraction of 0.2 for argon, that means that 20% of all of the molecules in this container is argon. So let's say if we have 100 gas molecules, 20 gas molecules will be argon, 30 gas molecules is oxygen, and the other 50 gas molecules is nitrogen. So the mole fraction is simply the decimal form of a percent. So the container has 50% nitrogen, 30% oxygen, 20% argon, not by mass, but in terms of quantity. So now let's calculate the partial pressure of each gas. The partial pressure of argon is going to be the mole fraction of argon times the total pressure. The mole fraction of argon is 0.2 times the total pressure of 1,000. So 20% of 1,000 is 200. So it's going to be 200 torr. Now let's calculate the partial pressure for O2. So that's going to be the mole fraction of O2, which is 0.3 times the total pressure of 1,000. So this is going to be 300 torr. Now let's do the same for N2. The partial pressure of N2 is going to be the mole fraction of N2, which is 0.5 times the total pressure. So this is going to be 500 torr. According to Dalton's law of partial pressure, the total pressure is the sum of the individual partial pressures. So if we add 200 plus 300 plus 500, this will give us a total pressure of 1,000. Let's try this problem. So we have the mass of N2 and O2, and they're mixed in this 2-liter container at 300 Kelvin. Let's begin by finding the partial pressure of each gas. So let's use the ideal gas law equation. PV is equal to nRT. Now in order to use it, we need to calculate the moles of each gas. So let's start with 56 grams of N2. The molar mass of N2 is 28 grams per mole. So 56 divided by 28 is 2. So we have 2 moles of nitrogen gas. Now let's do the same for O2. The molar mass of O2 is 32 grams per mole. And 96 divided by 32 is 3. So we have 3 moles of oxygen gas. So now we can find the partial pressure of each gas. So if PV equals nRT, P is nRT over V. So the partial pressure of N2 is going to be the moles of N2 times RT divided by V. So that's going to be 2 moles of N2 times the gas constant R, which is 0.08206, times the Kelvin temperature of 300 divided by a volume of 2 liters. So these two cancel, and it's just going to be 0.08206 times 300, which is 24.6 ATM. So that's the partial pressure of nitrogen gas. Now let's calculate the partial pressure of oxygen gas using the fact that we have 3 moles of O2. So the equation is going to be the moles of O2 times RT divided by V. So we have 3 moles of O2 times the gas constant times 300 Kelvin divided by 2. And you should get 36.9 ATM. So now that we have the partial pressure of O2, we can use Dalton's law to calculate the total pressure. So the total pressure, it's going to be the sum of the 2 partial pressures. So that's 24.6 plus 36.9. Which you should get 61.5 ATM. So that's one way in which you can calculate the total pressure, if you know the partial pressures. Now you can also calculate the total pressure using the ideal gas law equation. The total pressure is going to be the total moles times RT divided by V. So we had 3 moles of oxygen, 2 moles of nitrogen, so we have a total of 5 moles of gas times the R constant times the Kelvin temperature of 300 divided by 2 liters. So this would give you 61.5 ATM. So you're going to get the same answer. Let's try one more problem. A storage tank contains nitrogen, oxygen, and carbon dioxide. We have the partial pressure of N2 and O2, and we have the total pressure. What is the partial pressure and mole fraction of CO2? So according to Dalton's law, the total pressure is the sum of the individual partial pressures. So that's the partial pressure of N2, O2, and CO2. Now we know that the total pressure is 600. Not 600, but 825. The partial pressure of N2 is 600, and for O2, it's 150. So let's solve for the partial pressure of CO2. 600 plus 150 is 750. So the partial pressure of CO2 is going to be 825 minus 750, which is 75 torr. Now that we have the partial pressure of CO2, we can calculate the mole fraction. The mole fraction of CO2 is the partial pressure of CO2 divided by the total pressure, which is 75 divided by 825. And you should get 0.091 if you round it. So about 9.1% of the molecules in the container is carbon dioxide. So that's it for this video, and thanks for watching.